Hello, my name is Izwan Shah bin Ahmad Sanusi, and I am year 2 student at UTHM. So today I want to explain about the plasma cutting arc. If you are in the metalworking business, you have heard about the plasma cutting system. Plasma combination of cut quality, productivity, and versatility make it one of today's most popular industrial cutting processes. But first, what is plasma? Plasma is often called the fourth state of matter. Let's take a look at the three other states we are familiar with.
They are solid, liquid, and gas or steam. The difference between these states is their energy. When you add energy to ice in the form of heat, the ice melts and forms water. If you add more energy, the water vaporizes and becomes steam. From ice to water to steam. But what happens if you add even more energy to the steam? A lot more. If you could heat it to 11,700 degrees Celsius, the steam would break up into a number of component gases. It will also become electrically conductive or ionized. This high-energy ionized gas is called plasma. Plasma is created when you expose a gas to very high temperatures or when you pass electricity through it. Our most familiar form of plasma is probably the gas inside a fluorescent or neon light bulb. Lightning is an example of plasma on a larger scale. And on a very much larger scale, our sun and all the stars are also made of plasma. Plasma is quite remarkable. It has no specific shape. It is also a bit like a metal in that it easily conducts electricity and produce and responds to magnetic fields. Because of these unique properties, plasma can be tremendously useful, which brings us back to metal cutting. Now that we have a better idea of what plasma is, let's see how it works. Here is the inside of the plasma torch, the kind typically used on cutting tables. Compressed air, nitrogen or other gases provide the source for the plasma. In this example, a second, inert shade gas is used to protect the workpiece and blow off melted metal. Electricity supplies the energy needed to turn the gas into plasma. The greater the current, the hotter of the plasma. A special engineered nozzle and electrode constrict and maintain the plasma jet, concentrating it into a small area, so it can be used for cutting. When the operator is ready to cut, the start signal is sent to the DC power supply. The circuit temporarily connects the nozzle to the positive side of the power supply, with the electrode at negative. Next, the high frequency spark ionizes the gas and make it electrically conductive. This creates a current path between the electrode and the nozzle and forms a pilot arc of plasma. The workpiece is connected to a ground through the cutting tables. When the pilot arc contacts it, the plasma arcs transfer to the workpiece, melting the metal to the high velocity gas blaze the molten material away. And that brings us to the end of our brief journey into the fourth state of matter.
The advantages for the plasma cutting arc is first, able to cut all conductive materials. Flaming cutting, though also suitable for cutting thick metals and is limited to ferrous metal only. Second is great quality for thickness, which is up to 50 mm, and it is the best way to cut medium thickness stainless steel and aluminium. And last but not least is CNC machines are available to provide high precision and repeatability. For the disadvantages for plasma cutting arc is first, quality with thinner sheets and plates not as good as laser cutting, and tolerances not as precise as laser cutting, and does not reach thickness like flame or water jet cutting.